Hello, I'm Paldin Eivaz.
Hi, this is Garman Chan.
I'm Jin Matsumoto.
And this is Team Jarvis for the Engineering 6 Urban Development Project for winter 2014. To start off, we're going to go through the graphic user interface and then show the code behind it.
Hi, allow me to introduce myself. I am Jarvis, a virtual artificial intelligence available to assist you through the following project as best I can. If further help is required, please select the Help button for more details. Let's proceed. To start off, choose a city of your choice. Then select a product from the solar panel and/or wind turbine option. Beneath the item you have selected are the specifications of that product. To insert markings, select a city and place the panel or turbine in an area of your preference. Then select another product of your interest and place it on the map.
After, press Calculated Cost to calculate the total cost of the products together.
Calculated cost is shown on the right.
Then press Solar to calculate solar potential energy.
Estimated calculation for solar energy intake completed. The units are kilowatts per meter squared.
Or press Wind to calculate potential energy.
Estimated calculation for wind energy intake completed. The units are kilowatts.
To save, press Current Image and this goes into your directory. Then press Save Text to save the current file to continue working on it later.
Saved into your current directory as image.txt file.
Press Reset to start over.
You have now reset the entire graphic interface.
Press Open Save File to open previous materials.
Setup is complete. You may continue to work on your planning.
Finally, press Bill of Materials to look at the quantity, price, and the product name.
Bill of Materials is now in your current directory as bom.txt.
Okay, so now we're going to go through the code behind the GUI. So when you run the M file, the opening function is called, and the AI is run, the audio file, and it guides the user through the project. And once the user selects a city, we obtain that value and we globalize the variables, the number of clicks, the number of panels, and the number of turbines, and set them all to 0. Once the user picks a city, the case 2 would be Boston, and we would read the image of Boston in and lay a grid over it. And we would do that for each of the cases for San Francisco and Los Angeles. Right, so after the user has selected a city, they can select a solar panel or wind turbine, and we would obtain that value. We globalize the variables, and we have 2 cell arrays that have the specs of each solar panel or wind turbine. So say the user picks case 5, which is this first solar panel. We would display the specs into the static box, add 1 to the number of clicks, subtract 1 from the remaining number of clicks. If the number of clicks exceeds 20, we'd have a message box display an error. And After the user has selected a turbine or solar panel, we would allow them to click on the map to select where they'd like to place it, and we would color code it depending on which solar panel or wind turbine they chose. And we would add one to the number of panel 1, which is the first solar panel, which displays the number of boxes filled in with the first solar panel. We would do that for each of the cases for each wind turbine or solar panel. So after the user has completed placing all of his solar panels or wind turbines onto the map, you can click the Save as Text button, and this will save all of the information, the number of panels, number of turbines, number of clicks, remaining clicks, and image contents in a variable. And then we would write the image into the image.txt file, delimiting each image content by a comma. If the user would like to open their previously saved text file and load the image back in, you would click the Open File button, and we would return all of the saved information back into the original variables, and we would read the image back into the axis.
Okay, so once the user hits create bills of material, it will link it back to the function create BOM callback. Then it will globalize the variables. Afterwards, we create a variable called BOM to store the different products, quantity, and cost into a cell array of 20×3. Then the system computes it. Afterwards, once the system computes it, then it would display it back to a text file here. Alright, so once the user hits the calculate cost button, it would link it back to the function calculate button callback. It would then globalize the variables. Then we input the prices and the dimensions. Afterwards, the system would display the total cost. Alright, so once the user hits the solar estimate button, it will link it back to the function solar estimate button callback. Then we globalize the variables. Then we index the cities. Afterwards, the system does the calculations to calculate for solar potential.
Once the user clicks the Save Image button, the image is saved, along with all the progress the user has made, and is written to a PNG file. When the user clicks the Reset button, all the variables are set back to 0. The image is reset and the user can continue. When the Win Estimate push button is pressed, weather.mat is loaded. We first find the city index, then we find the wind potential by multiplying the number of turbines in the box by the number of turbine the user has chosen. We then multiply that by the wind average of the city chosen to get the potential and display the result. When the Help button is pressed, a user-created function pop-up message is called, and that tells a user how to use a program.